All right, so week 3, we're largely going to talk about the where clause, and I know we spent a lot of time kind of talking about the where clause last week, but there's some specifics, and most of them are pretty straightforward, especially if you've ever programmed before. Really, just conditionals is what this week is greater than, less than, equal to, and understanding the whole true and false thing. So we'll cover a couple of examples of that, but also the biggest thing I want to talk about this week and make sure that we're all up to date on is the final project option, or just making sure you understand the final options. So we'll actually dive into the final first, and then we'll kind of circle back and kind of finish off with the where clause, if that works for everybody. So anyways, the final project, really you have two options for the final. One is the final project and one is an exam. So both are worth the same amount of points. You only can get points from one or the other. You can't do half of both, if that makes sense. You can do both, but the best score from either will kind of be your final score for that kind of category. So basically, usually what I do is when it comes time for the finals to come around, I just kind of go in the grade book, and if you turn in one or the other, I'll excuse the other. And if you turn in both, I'll just see which one has the highest score and excuse the other. I will say that I highly encourage the final project versus the final exam. I think it's way more enjoyable for you. And I also think you learn more. In fact, some great feedback someone gave me last term was that they actually thought they said, out of everything in the class, they said, I think I learned the most from the final project, which is perfect because we actually kind of coordinate a lot of the final project with the course material. So why I strongly encourage it is because as we kind of go through the rest of the course, I actually will many weeks actually work with a final project, doing an example, and I'll always kind of relate that back to a final project. So I highly recommend it. And as another note, basically, as long as you put forth the effort and have the deliverables, I can almost guarantee you an A 100% on the final. Can't say the same thing about the exam because that just depends on how well it performs. But what I like about the final project is that you can kind of do it, and you can always get it to where it's about done. I'm happy to review it before you can submit it. Let me know, and if you get it in, and there's still some time, you can always make any corrections if it needs them. But most of the time, like I said, if you have the deliverables and you've and the efforts there, it's pretty much 100%. I've only seen a couple that were pretty clearly done last minute that haven't gotten 100%. But if you're working on it throughout the course, like it's kind of designed, there's just pretty much no worries there. And so that's kind of the option. So you kind of get to pick and choose. It's a choose your own adventure kind of a system. But I kind of want to go over what's in the final project so we can, so you kind of go into it kind of knowing what you have to do. So really, when it comes to deliverable, there's really just a few things. So we create an ERD with a minimum. This says 12. My minimum is actually 10. So it says 12, but as long as you're at least 10, that's good, because there's just some situations where adding more becomes more of an exercise than it is useful, and I don't want that. So I really say like 10 to 12. And we've kind of already kind of walked through some of this, and we're going to kind of build some of these together as we talk about things. So last week in the video, we kind of did a quick Canvas one. So it'd be just like that. And what's cool is you can actually build your ERD in MySQL Workbench and have it auto generate the code to actually build your database. So to me, the ERD is almost not even it's a deliverable, but really that's just you designing a database, right? And then the second deliverable is test cases. And so we call these CRUD statements, which is pretty standard in the industry. And they're create, read, update, and delete operations against the 10 to 12 tables. So basically what this is simulating is as if you were going to go out and actually bring this product to market or actually build this. It's super helpful to already have these pre-made, though this is how I insert into my, like, for example, let's say we were doing a cookbook with a recipe. This is how I insert a recipe. This is how I select my recipe. This is how I update a recipe. This is how I delete a recipe. And you'll do that for all your tables. And then that way, they call these CRUD statements because when you build like an API or whatever you use to kind of connect your database to an application, that's already there. So that way, for example, if we were making an app, and you have that button that says delete, you can just connect that to code that already exists. It's pretty straightforward. And in this case, it's kind of a proof of concept. So anyways, with the understanding of knowing that those CRUD statements are, there's some additional test cases. So basically what we do is we create what's called a UI map. And a UI map is basically, this is where you get to kind of dream up what you would have the user interface kind of look like. And then from that, for every kind of major action that you kind of take on there, you can kind of come up with some stuff that goes along with it. So I'm going to show a quick example here of a UI map. So this is one that I did, and granted it's not complete, but again, going back to recipes, this is kind of what my UI would look like if we were going to create a recipe. Let's see if we can scroll here. So here you can see, like, I kind of just really, like I said, it can just be quick wireframes. I have a couple really nice tools that are readily available for free that you can use to do something just like this. But you can see I've kind of labeled some things. So if pretend this is a web page, I can click like a drop down, select what cookbook I want it to go into, click here, type in my recipe name, put in the estimated prep time in minutes, and then kind of put a description of the recipe and hit save. And you'll notice like the bulk of this, like there's two kind of ways. I mean, you can type stuff in, but as far as things that might happen that connect to the database, this one, when I click a drop down, it needs to get a list of the cookbooks. So this cookbook.r.2, it corresponds with some test cases. And those test cases I have actually right here. So I kind of used like a kind of like that naming convention. So C or R.2 cookbook R.2. So if I go to cookbook R.2, this is the select statement that will power that dropdown, right? It's basically just get all the cookbooks that I belong to, because this whole database, we'll talk about it, but it's built around, like family cookbooks. So people can kind of have like shared family cookbooks. But anyway, so something like that. So that's the UI map, and then you build your test cases now. And a lot of the test cases will actually already be in your CRUD statements. So once you create your CRUD statements, then it's just a matter of kind of like doing the fun kind of part of the database where you get to kind of like select what you want. Obviously, we just talked about the UI and the test case SQL script files, which is what I just showed you. So this is kind of all encompassing. So you'll have SQL that kind of maps out to the user interface, if that makes sense. Kind of like how I did, where I said R.2, and then you can go in the code and, oh, if I click this, R.2 is what gets that data. Same thing with like the save button. If I hit save, it's going to insert into cookbook and that sort of stuff. Now, it doesn't have to actually be functioning. It just has to like be like very just an example. So like in my case, I just use like Bilbo Baggins or Samwise Gamgee or something like that. And I just, and for my example, my test case is just creates a recipe for rabbit stew. So anyways, so simple. It doesn't actually have to be functioning. You don't have to build any UI. This is purely focused on the database. And then we do just enough daydreaming essentially to kind of put a wrapper on it. And then the last thing you'll do is you'll just create a PowerPoint that just kind of walks through it. So to kind of wrap this all up, what I like to think about the final as is, imagine you have this idea for a database. You need to proof of concept it, right? You need to proof of concept it, show that it works, show that it's well thought out, have the stuff already. So that way, pretend you're going forward with like to your project manager to say, hey, this is what I built. I think it'd work great to solve this problem. Can the team adopt it so we can bring it to life, essentially? And that PowerPoint should kind of be focused on that. Like if you pretend that I'm an investor or something, and I'm the one that's going to kind of help you bring your project to life. Talk about what the business purpose of your model is. Why are you building it? What is it going to do? Who's it going to serve? And then you can kind of just then like walk through your UI and say, this is where someone does this, and this, and then you can kind of just really go over your ERD to kind of say, and I designed it this way because, if I design it around families, this person can be in multiple families, in case he wants to be on his in-laws cookbooks as well, and walk through some of those various design kind of stuff. And on this page, you can see the rubric. It's really pretty simple. So is your database designed well, which you guys all will be, because we're going to talk about how to do that. Really, do you have all your CRUD components? And then do you have all your test cases? So really pretty standard, pretty easy rubric. And the key to this is that you start early. So what I'm going to do is I will share some resources out this week. Basically what I'll do is I'm going to kind of shoot out some examples. But really this week, what I'd like to kind of, and you'll also see in the weekly announcements, I like to keep kind of hey, this is what you should be working on if you're doing a final project. So that'll kind of happen. And then, so I'll kind of keep you on pace that way. So to kind of get started this week, what I would kind of recommend is start thinking about what your project might be. And keep in mind, you don't want it to be outrageous. You want to kind of keep it, bite-sized, but still kind of big enough that it can do 10 tables minimum. So what I would do is I would just kind of start. I have an iPad with a pencil. So I always, like, if I'm kind of dreaming up this stuff, I just start with little circles, then I'll just write names on them and then draw lines, right? Just kind of say like, oh, if I have a recipe table, I'll make a circle with a recipe. Here's a cookbook, and recipes belong to a cookbook. And then, oh, I have a family table and cookbooks belong to a family. And there's people in a family. So I have a family member and then I have a person. Anyways, you guys kind of get the picture. So I kind of start that way, and then I'll kind of bring it into something like Workbench, where you can actually kind of start designing it. So next week, what we'll probably do next week we'll actually kind of start putting one together in real time, so you guys can kind of see it. We'll walk through an example of one that I will make, and we can kind of go through it that way. So hopefully you guys have an example, or if someone can think of a good idea, I'm happy to kind of use someone else's as kind of like an example too, if you're comfortable with that. But anyways, any questions about final options, the exam or the final project? Okay. Take that as a good sign. So anyways, let's dive into week 3. I think this is actually a pretty light week, which I think is excellent for getting started on your kind of final project. should be relatively, for most people should be mostly review, because a lot of this is kind of just pretty simple, like condition type stuff. There's a couple nuance here and there, but pretty easy to kind of get up the curve on. So ultimately, whenever we do a where clause, we're filtering out data. And the way we filter out data is we use conditional statements. And the way we write those conditional statements, basically each statement, or the entire statement, the entire where clause must evaluate to true or false at the end of the day. Because at the end of the day, it's going to basically go row by row and make sure that it matches all the criteria listed. So in this case, where first name equals Stephen, okay, so let's say let's say my name's Stephen, and the create date is greater than 2006 January 1st. So if my name is Stephen and I was created in 2005, I'm not going to make the cut because of this and, right? So if I have an and, both of these must equate to true. If now if I was created after 2006, I would make it through, obviously, because both equate to true. Now, if there was an or here, then I would make it, because my first name's Stephen. I wasn't created, but I was created in 2005, so this one is false. But as long as one or the other is true, you're good. So the one thing that I will say, which I'm glad this is the next slide, using parentheses in this is extremely important. So a lot of times, even though it's not necessarily required, I always do it because it helps me read it and just gives me confidence in what I'm doing. So you'll notice this one, it says where this or this and, because of the whole statement is really one, consider the where clause as one giant conditional. You kind of have to wrap this up, because if we didn't have these parentheses, are we saying where first name is equal to Stephen or last name is equal to Young and the create date? So is it last name and create date, or is it, this or this? You can see what I'm saying. It can get really confusing. So in this case, what it's doing is just like math with the parentheses, it evaluates that first. So, hey, is my first name Stephen or my last name Young? So if my name is Stephen Crook, is this going to evaluate to true or false? Well, we're going to look at across the entire parentheses. So first name is equal to Stephen. If that's yes, then it doesn't matter what my last name is. I'm going to make it through. If my name is Bill and my last name is Young, I'm going to make it through. But if my name is my real name, Tanner Crook, obviously I'm going to fail before I even get started. And so this other one doesn't matter. But let's pretend my name's Steven. We don't care about my last name, or let's just pretend my last name's Crook. So I make it through regardless, and create date, well, I was created in 2005. So I don't make it through because of this and, right? Because as long as this evaluates to true, it says this whole thing must be true and this must be true. Well, this was true, but this is not. So I would be excluded from the results. All right, so an easy way in SQL to kind of like just flip something is you can just say not, right? So basically, if we want to immediately antiquate this and say, hey, I want everyone who's the opposite of the parentheses, we can just put this not clause in front of it. And you can kind of see they rewrite it. So again, if my name's Steven and my last name's Crook, in this case, because of the not, this actually evaluates to false. The first name is Steven. Because that's true, because it's true and we have this not, it's actually false, because it kind of breaks it the other way. Because really what we're looking for is people who are not Steven or last name is equal to Young. Now, my last name is not equal to Young, so therefore this is true, but for the opposite reason. Before I got through based on my first name, but now I got through based on my last name. And the not only applies to the first thing, it would have to be and not here as well. Does that make sense? Anyone confused on this? The not. Yeah, I got a thumbs up. I'm guessing that means you're good. Makes sense. Okay. Equal conditions are super easy. Inequality conditions, you could either use open, close, greater than, less than sign, or you can use the exclamation mark equals. Completely up to you. I'm an exclamation mark equals kind of a person, just because I guess you could say I was raised up on the old programming languages, so this was a little weird to me, but either one works. Yep. Range, so you can do like dates greater than, less than, and obviously numbers greater than, less than. You can also do between. So specifically with numbers and dates, you can say, hey, and they're missing an A here, but is the rental date between this and that? And it's inclusive of this. That's an important note. So rental date, if the rental date was 2005, June 14th, it would still be included, because basically it's an upper and lower limit. So it's inclusive of those limits. But as long as it's between those two things, then it'll work. The in operator basically checks a list. So is the rating in G or PG? So this is really handy if you're doing like a list of things. Like as long as it's one of these things, I don't care, because that way we like this, because otherwise you'd have to say where rating equals G or rating equals PG. You'd have to do the column name twice and an or, and this way is easy because you can just say where rating is in, and as long as it's one of those things, it does all the logic for you. Any questions on this one? Or is it clear? Thumbs up. Good. Okay. All right. So subqueries. So the in clause is really handy because we can use subqueries to kind of auto populate those things for us. This one's kind of a confusing example. I don't like it as much. So let's try a different one. Let's try a different one. So if we take a look at what tables do we got here? So if we take a look at our, let's say, our customer table, we have select everything from the customer. And let's use, there we go. So if we take a look in our customer table, you'll notice that we have just normal customer info. We have like the store ID, the last name, first name, and that sort of thing, right? So we also have this other table called actor. And let's say that we are bored one day, right? And we're working the counter, or we're DBAs at the video store, and you're sitting there with your coworkers and you say, hey, I wonder if any actors, like, or relative of actors, are our customers as well, right? And you make bets, and everyone's huddled around the computer to see who's right. How would we go about that? Well, let's say we just wanted to simply say, hey, I want to know if anyone with the same last name, because like, let's say, we see Wahlberg, we see some of these famous actor names. Do we have any of these last names that are customers? So what we can do is we can say select everything from customer where last name is in, and then here we can say select last name from actor, right? And so selecting last name from actor, that's just going to give us a list of last names, right? We can even run this by itself. Select last name from actor. we can run this, and you'll notice it just gives us a list of last names. And you'll notice that there's a couple like duplicates. You see how I have Guinness 3 times? So I'm going to add a keyword that says select distinct, which basically means, hey, based on my output, so in this case, just last name, remove any duplicates. So now if we go down to Guinness, you'll notice that we only have one, which is perfect. Now that's not required. We could just list it as is, but just so we're there, because I like to be thorough. So select distinct, because we just want one of each last name, and it's going to check. So it's just going to use this as a list, which is quite the list, but we're going to see if we have any. And we do. We have actually how many? 22 of them. So we have 22 total customers that have the same last name as an actor. So, at this point we could kind of go through and, given that they were real actors, we could theorize and whatever. But that's where subqueries are really handy with that in clause. Any questions on that? I see a hand raised. Is that a question or is that good?
I did have a question.
Okay.
It was that the one that you were looking at before, the example that you said you didn't like, before the meeting, someone mentioned that they were confused by that one. And when I started looking over it, I couldn't understand it either. It's the one select title rating from film, where rating in, and then it uses the percent signs with the letters PET in between. And we were just confused as to why the letters that are in between the percent signs don't appear in the title of the films anywhere, because that's what it looks like it is saying.
Yeah, and we're gonna get there. That's why I don't like this example, because it kind of gets the cart before the horse a little bit.
Oh, okay. All right, thank you.
Yep. And just like before, the not is gonna do the antiquate of that. So like back to our example, it would pull everyone whose last name is not in the actor last names. So not kind of works the same across all of it. Okay, so this is exactly where you're going with your question. So this is our oh, and I see another hand. Does someone else have a question?
Yeah, sorry. I was just wondering what the purpose is. The purpose of the subquery kind of replacing an inner join in a little way, because I noticed you use the actor and the customer in the same statement without joining them.
Yes.
Is that kind of what it does?
Yep. Yeah.
Okay.
You'll find
that's what I thought, but I just wanted to be clear.
Yep. Yeah, because you'll find that one nice thing about SQL is it's very flexible. But each one of those comes with different kind of performance implications, so to speak. So what I like is once you kind of understand how it works at a deep level, which is why I kind of like to explain things, is because you'll hear SQL tuning is a real thing that people need to do all the time, which is basically optimize our queries. So yeah, we could do this another way with a join. And I don't want to get too much in the weeds here, so I'm actually not going to show it, because we're going to talk about joins, I think, next week. But ultimately, yeah, you're correct. We could join this data together instead, and kind of get the last names that way. But in this case, because it's in the where clause, it actually is pretty efficient, because it really just kind of pulls like a distinct list. Where we really try to avoid subqueries is in the select clause, because then it runs it on a per record basis sort of a thing. And sometimes here it can run up per record as well if it's and again, we'll talk about this in future weeks. But if it's a correlated subquery, then it will run for each row. But in this case, this is, like I said, it's pretty flexible. So, hey, I just want to get the distinct list of last name from actor and throw it in there. So, and sometimes the joining adds more confusion than it alleviates. So that's why I kind of actually like this method, because because we're only getting data from the customer table, we don't do any multiplication of data or anything like that. And again, we'll talk about that when we get to joins. But yeah, great question. Cool. So anyways, let's talk wildcards. So back to those weird percent signs in the film title. So oftentimes we want to search for things, and you guys can think of probably a million examples of websites where you're searching for a specific record or data. You're searching for data, and we live in a generation, a society where we only have to type like the first 5 letters and we can have it automatically generate results, or we can just hit enter, and 9 times out of 10 it pulls up what we're looking for, right? And so this is essentially what these wildcards do, is they let us look for things that are kind of fuzzy, right? Like we can find like little sub pieces of things. So going back to let's go to our film table. We'll kind of use that one. So let's select everything from film. And let's just select, actually, let's do the title and the description. Right. And so let's say we want to look for any film that has to do with dinosaurs, right? So I'm going to say where description like, and I'm just going to put dinosaur in these parentheses, or sorry, in these percent signs. And these are our wildcards. And basically the way these work, if I run this, well, it doesn't find anything. Let's try teacher. Oh, wow, we have a lot of teachers. Let's try computer. Nothing. Dog. Lots. Pet. Nothing. Okay. If we were looking for something particular, let's do science. We'll do teacher. Let's use Rockies just as an example. Trying to get it down to something smaller. Oh, wow, there's lots. Okay, it looks like they just kind of pick random things. Anyways, so you can kind of like use this as a fuzzy search. And basically what these wildcards do is, as long as Rockies is anywhere, really anything can be in front of it and anything can be on the other side of it. As long as Rockies is somewhere in there, it'll work. On the flip side of that, so like if we're looking for, like, let's say we know that there's a movie that has dinosaur in it, right? In the title. So we're going to change this to title. Now, if we were to just say, oh, I know this movie started with dinosaur, we could do this, because then, only movies that start with it. So dinosaur secretary is we only get that. Now, if I were to flip this and say, oh, I know the last word of the movie was dinosaur, we can do this. And now you can see we have academy dinosaur and center dinosaur. So this is a really handy way where you can kind of, use this to kind of say, hey, I don't care what's in front of it. I know that the string, the column ends with the word dinosaur. So you can kind of just like plug that in there. And then there's the underscore, which means like, hey, I know that there's exactly, one character in front of it. So like, let's say that it was something like this. So let's go back to description. And let's say you didn't necessarily know what came first. Like, let's say it was a letter, number, or something, but a something, So basically the underscore means, there was something there. You just don't, because like the wild card means anything, any number of characters, anything. The underscore means that there's at least one character there. So like if we were looking for a movie called 27 Jump Street or something, you know, you would do underscore and then, you know, let's say there was like 12 different movies that were numbers in Jump Street or something like this. Let's say the title of the movie is Harry Potter sequence number, and then we don't care what the rest of the movie is. Something like that, you know, like you could, you know, 1, 2, 3, 4, it doesn't matter as long as it's there. Cool. It's lots of wild card stuff, but I think we got it. Nulls. Null handling in SQL. What a null is it means it's empty. So let's take a look at, select everything from, let's do address, maybe. All right, so you can see here that there's some addresses and some of these have nulls and some on address 2 and some of them are just blank. These ones that specifically say the null. So let's see how this handles this. So we do select everything from address where address 2 is null. You'll notice that we only get these. But if I say where address 2 is equal to basically nothing, so I just do a single quote, you'll notice I get more, but none of the nulls. So this is a data cleansing issue where basically we have some dirty data, because I like to get rid of these are like the bane of my existence. I don't like these, because then what you have to do if you want to find everyone that doesn't have an address 2, you have to do stuff like this where address 2 is null. Right, so now we'll get all of them as long as they don't have an address 2. So I like to clean these up. I like to see these nulls here. If it's empty, I like it to be null, not what's considered an empty string. And you'll notice that equal to only works with a value. So if I try to do this as equal to null, you'll notice that it actually fails. So it has to be is null or is not null. Does that make sense, everybody? Nulls. They're different from just being empty. So there's empty, and then there's null, and then there's something that has something. So they're 3 different things. Okay. And that's that. Cool, that's filtering. Does anyone have any questions? There's Mud. Perfect. All right, well, I will call it there. If something comes up somewhere along the way, feel free to ask me. Otherwise, be looking forward. I'm gonna send out some kind of resources to kind of maybe get your mind going a little bit on final projects. But otherwise, have a great week, and let me know if you need anything.
Thank you.